This is a brief demonstration of redundant internet connectivity with Fortigate routers. This site here has cable, mainly because it's cheaper than fiber. And something that I've been noticing here is that the cable signal is somewhat intermittent, meaning that every now and then the cable modem will lose signal from somewhere upstream, which will eventually cause the cable modem to reboot. And this is not an uncommon issue, but it is an annoying one, to say the least. Every time that happens, internet connectivity is disrupted for a couple minutes. So I thought, why not set up a failover to dial up internet, since there are multiple phone lines here, multiple POTS lines that will stay operational in the event of a broadband outage. So I'm not going to go through all the steps here, but some of the important ones to note. So this is the interfaces page for the WAN 2 interface. So there's obviously a corresponding one for WAN 1, which I won't go into. But the important things here, the distance here I've set to 11, so this is greater than the distance for the WAN 1 interface, which is the important thing. And you'll notice the default gateway here, that address is actually the default IP address used by Windows Internet Connection Sharing. And so what I have set up here is I have this Windows machine that is connected to this modem here. Let me turn it on. And this is set up with internet connection sharing. So if I go to the properties of this modem and I go here, you can see that it's set up to allow anyone to use this connection. And importantly, when there's traffic from the local area network through the WAN 2 interface on the Fortigate, that will automatically cause the machine to establish an internet connection. So this is a popular arrangement if you're using a single machine with a dial-up modem to obtain internet connectivity for an entire site, which is what we're trying to do here as a failover mechanism. So that's what this machine is here. And then here I have a static route configured for WAN 2, as you can see. And again, the distance is 11. The important thing is that it's greater than the distance for the WAN 1 interface. And the priority is 1, again, to be greater than the priority for WAN 1. And then here I have a firewall policy to allow egress traffic on WAN 2, and this is stateful, so responses will be allowed. And importantly, I've whitelisted only a few protocols for this interface. And the reason for that is if I were to just allow everything, then all kinds of traffic that would be perfectly okay on a broadband connection would absolutely just bring the dial-up connections to its knees. And really, if there's a broadband outage, I don't need all kinds of random stuff like SIP ATAs or gateways, stuff like that. I don't need any of that working. I really just need the important stuff. So here, DNS, because obviously DNS is important for pretty much most other protocols. HTTP, if I wanted to do some web browsing or something like that. Ping for diagnostics, SSH. Of course, for SSH, that's pretty self-explanatory. WireGuard, there is a site-to-site VPN tunnel between this site and another site. And so I have that in there so that any traffic that would go over that tunnel can continue to do so in the event of a broadband outage. Or you need to set up a link monitor in order to actually be able to detect that. So what this will do is, here we're pinging 1.1.1.1, that could be anything, but pick something that should always be reachable, and we're pinging it every second, and if it fails twice in a row, we're going to initiate failover to WAN 2. And if the ping is successful just once, then we'll end the failover and go back to WAN 1. Now this last one here I have seen conflicting documentation and commentary on. Some places say you need that enabled so that you'll automatically disable the default route, which can make the failover work in the first place. I found that it works just fine with this disabled, and the problem I was noticing with this enabled was that when WAN 1 came back up, the traffic would continue going out WAN 2 for several minutes afterwards, and I wanted it to immediately switch back to WAN 1 when it was operational to minimize the amount of time that we were on the dial-up connection. So that's why I have it disabled, because when it's disabled, it seems to flip immediately back, which is the behavior that I want. Alright, so I'm going to jump into a brief demo here. Here you can see that we have some pings that are running in the background. The one on the left is running on my local machine here, just in command prompt. The one on the right is a remote terminal session that is going over that WireGuard VPN tunnel. So we're just doing a continuous ping to monitor what's going on. And we can initiate the dial-up failover here. So let me close this. The modem's on and connected, and I'm not actually going to do anything to the modem, but what I can do is I have a simple 1 in, 2 out, or 2 in, 1 out switch here that I can use to physically switch from, in this case, this cable on the right to nothing, since there's nothing plugged into the left. And that will allow me to manually initiate a failover, so let me do that. And pretty much as soon as we do that, within a second, we see that the dial-up connection is already initiating. And in the meantime, while that's happening, of course, our pings are timing out on the left. Of course, our SSH session is sort of in limbo because that's, again, that's remote printout, so we're not getting anything there right now. And right now we're just waiting for negotiation to finish. And that's almost complete now. It's just verifying, registering. And alright, we are online now. We're online at 33.6 actually. And voila, just like that, our pings are now succeeding again. Of course, you can see that the latency is quite a bit larger than it was on broadband. And it's not 100% reliable. Some of our pings do time out, just because the bandwidth is so limited. But by and large, our pings are succeeding, just with latency that is, gosh, several orders of magnitude larger. But they are succeeding nonetheless. Now, I want to shift focus to our terminal session on the right. Notice that our terminal session is still alive. Now, by default, so I'm actually using Kitty, which is a fork of Putty. And by default, Putty and its variants are very prone to timing out if there's any kind of a brief network interruption. So the way that I worked around that, because the primary requirement of this failover mechanism, let me wake that up, was that SSH sessions would not drop in a broadband outage. And Windows has a relatively short retransmission time for TCP or something like that, which would cause Putty to time out the connection. So there is a registry key that you can change, and I'll leave some information about that in the comments. I'm not going to go into that here. But if you update that, if you increase that to a larger value, then that will make the connection a little bit more resilient against brief network disruptions. Now, it's also important, it's not a coincidence that this connection is going over a WireGuard VPN tunnel in this case, that site-to-site tunnel that I mentioned. If it were just to some host on the internet directly, this would not work, because the IP address would change, obviously, from going from the cable connection to a dial-up connection with some ISP. So the VPN tunnel is critical because that goes to another site where that allows the IP address to be consistent. And so that keeps the TCP session alive, even as we switch from cable to dial-up. And as you can see, the pings are still going. They're batched up a little bit just because of how slow the connection is. But we still have control over the session. You can see I hit enter there, and it's a little bit slow, not as responsive, but it does actually take effect. These pings on the remote session are still going. Now, the fact that I'm running the ping program here is not super relevant. I just wanted something running to demonstrate. But you could have something else going in this terminal session and it's still alive. So that is the great thing about this is if you have a bunch of terminal sessions active, now they will no longer drop when the cable goes out and you have to switch to dial-up for a little bit. Now, in this case, this would probably be sufficient on its own if the cable outage is only a couple minutes. It depends what you set those registry settings to. But in case it's not, having the dial-up failover allows some of this critical stuff to stay operational until the broadband does come back. So the ping times have gone down a little bit, it seems, here. So that's great. Now, what we're going to do here, since it's been a couple minutes, I'm going to switch WAN 1 back on. And you can see after a couple seconds there, the ping times are very good again, indicating that those pings have switched back to the cable connection. So obviously the duration of this disruption was significantly shorter switching back to cable than when we had to initiate the dial-up connection in the first place. So, and going back to our terminal session here, you can see it's significantly more responsive now because of the improved bandwidth conditions being back on cable. But again, we are still on the same terminal session. We started off on cable, we switched to dial-up, and we're back on cable now. And our terminal session did not drop. So that's definitely a bonus. Now, the only problem here that I'm still trying to resolve, if you go here, you'll notice that the dial-up connection is still active. And so I have a couple settings that are tweaked to be optimal for this connection. In particular, retry multiple times. If it fails, usually it doesn't. If it does, retry immediately because we're trying to get this thing up as fast as possible if we need a failover. The default is 60 seconds, which is huge. So retry immediately. And this is a useful setting. I think the default is 20 minutes or something like that. It's 10, 20 minutes, something like that, which normally you would want something higher so your dial-up connection doesn't time out. In this case, we're only using this for a short period of time, and so if it's idle for more than a minute, right, because there's going to be constant traffic that's using the connection while it's needed. But as soon as we switch back over to the main connection, to the cable connection, we don't need the dial-up connection anymore. So that's why I've set it to 1 minute. If it's idle, hang up. In practice, this is the one part that doesn't seem to quite be working yet. As you can see, it's been a couple minutes since we failed back, and the connection is still active. So something there is not quite right. Not a huge deal. I can easily set something up on the phone system side so that it, by default, will limit the connection to, say, 6 minutes, and then it will just hang up the line no matter what. And that way we avoid keeping that connection up longer than it's needed, because typically I'm only initiating these failovers for a few minutes at a time. They aren't needed for hours and hours on end. And if it were still needed for whatever reason, again, because we have that retry logic in there to redial if the line is dropped, if it gets cut off, it will just reestablish that connection. Not a huge deal. So that's something that you want to be mindful of and maybe test a little bit more, especially if you don't have a better mechanism of doing that. Especially the line that this is on, actually, we are paying 5 cents a minute for a long distance. So it's not something that you'd want to just walk away and realize that the dial-up failover was up for 10 hours when you didn't actually need it, and now you've got an expensive phone bill. But apart from that, everything is working pretty well, and the failover successfully allows important critical traffic to stay operational in the event that the broadband goes out. And if you have a Fortigate or a similar system, this is something that's relatively easy to do. You just need, in this case, we're using Windows Internet Connection Sharing, and it's built into any Windows box, and it's very easy to set up.